Okay, so the recording has begun. This is day number 2. Sorry, yeah, day number 2, because today is Tuesday. Day 2, week 6 of our journey together. And it's definitely a delight to have each and every one of you here. Albanique, Altonique, Caitlin, Cyan, Deshawn, Dylan, Miss Neely, and Jasmine. That's all we have so far. Thank you for being on time and for being here. I think Caitlin, is Miss Johnson with you?
No, ma'am. I mean, no, sir.
Okay. All right then. Okay, well, so Miss Johnson isn't there yet. Okay, so all right, so let's dive in. Um, Yesterday we was looking at probability. We still are on the probability journey. That's still the theme for today. Um, but we're looking at, so I'm gonna head up. So today is Tuesday, the 9th of August. Okay, so all right, so head up along with me. Uh, Today is Tuesday, the 9th of August 2022. The subject that we're going to begin with is mathematics, and the topic or the theme for the day is still still dealing with probability, and the theme for the past several math classes was we was dealing with sample space and events. And so we're looking at, okay, what do we mean by sample space? What do we mean by events? What do we mean by experiment? All right, those were some of the things that we look at. Like what do we mean by outcomes? What do we mean by we looked also at that was last night. We looked at the intersection. We looked at the union. We also looked at um, complement events. Someone mic is on. Yeah, an event and its complement. Right. So those are some of the things that we look at so far. Today we are actually going to provide finally the definition for probability, and I think this is going to put together a lot of things that we have been looking at. So we're gonna finally give the definition for probability. It's a very straightforward definition and formula. The way I'm going to present it today, a lot of people don't present it in this format, um, but it's still the same thing. So we're going to be looking at the probability definition, okay, and basically how to apply that definition for um, outcomes that are equally likely to happen. Okay, so the topic for today is the topic is probability model for equally likely outcomes. All right, probability model for equally likely outcomes. All right, so that's our topic for today. And so in this, we're going to actually provide, like I said, the definition of probability, the definition that we'll be using. All right, now this only works if the outcomes are equally likely to happen. Right, that means that there's no bias, there's nothing that is causing it to be unfair. Okay, so everything have to be fair all of the outcomes must be equally likely to occur. And that's why when we look at an experiment, we don't know the value, or we don't know the outcome that's going to happen. We don't know the outcome that's going to happen because everything is equally likely to occur. So we don't know what's going to happen in the experiment because everything is equally likely to occur. So heads is just as likely to happen as tails, you know, and getting a 1 when you roll a dice is just as likely as getting, say, a 6. All right. All of the outcomes are equally likely to happen. All right. And so that's what we mean when we say equally likely. So this definition that we be looking at only works when we have outcomes that are equally likely to happen. All right. Okay, so let's get into the definition. I know it's a lot of talking before we get the definition. So let's go. So take this down for me. I'm gonna put in our characteristic box. Then we like the box. All right. I should actually slim this down. I really should. Okay, good. And I should. All right, so let's consider this. So the definition, or the title of this, or the heading that we're going to use is the same as the topic: probability model for equally likely outcomes. Remember, when we say equally likely outcomes, that means that each outcome has the same likelihood of occurring, right? No one has an advantage over the other one. That's what we mean by equally likely. Okay, so let's begin to write. So in an experiment in which all outcomes are equally likely, equally equally likely to, let me space this out. So like I said, this only works when this formula only works when all of the outcomes are equal, have an equal opportunity, have the same probability of occurring. Okay. We model the experiment, or we represent the experiment by taking the probability of an event, call it capital E, to be the following. So here we're gonna provide the actual definition for probability. After all these classes, we haven't actually provided the definition of probability. This is the definition that you will see or that you'll be applying a lot in your exam questions. So in the exam questions, this is the typical definition that they want you to know, right? And for your age and your level, this is the only definition of probability. Well, this is one of them. This is the main definition of probability that you need to know. The main one out of all. This is the main one. And what is that definition of probability? Well, it involves some of the symbols that we've looked at before. So the way how we write it is we say probability, so P of, so it's saying the probability of an event E. That's how we read it, equals. It's actually going to be a fraction, all right? So probability is written as a fraction. It also could be written as a decimal and also be written as a percentage. All right, so we say probability of an event E, right? So probability of an event E, that's how we read that. So the probability of an event E is going to be equal to the number. Oh, before I give it away, anyone know? What's the probability definition? Anyone know the probability definition? Say it again.
1 over
It's a
2.
fraction. No, not 1 over 2. It's not always going to be 1 over 2. You know, when you're doing probability, what is the numerator going to be and what is the denominator going to be? Anyone know the probability? No.
Is this like ratio where you add up all the parts and then that's your denominator?
Okay, so it's going to be in your numerator.
Whichever part you're looking for or they ask for.
Okay, yeah, that's basically it. Yeah, that's basically it. Right? In layman's terms, yeah, that's basically it. So it's going to be the number. So the numerator is going to be, or the top number is going to be the number. Oh, by the way, as I'm writing, please take down these notes and right after class, send them to me so that I can know that you're following along. So probability of an event E is going to be the number of favorable outcomes. Okay, that is the outcomes that we want to happen, or that is the outcomes that is a part of our event. All right, divided by the total number of outcomes, all of the outcomes. All right. So basically, the total number of outcomes is going to be all of the elements that is in your sample space. All right, the total number of elements is going to be all of the elements that are in your sample space. So essentially, what we have for the definition of probability or the formula for probability is the top number is actually the number of elements that is inside my event. That is the representation that we give it. The number of elements that is inside my event. That's basically the number of favorable outcomes divided by the number of elements that is inside my sample space. All right. And that's the definition for probability, right? So this is the formula.
We can use this when looking for the tree too.
Yes, it's a part of it, but the tree applies another technique, all right, as well. Okay.
Start with number of events.
Okay, so let me make it very clear to you. So NS is the number of elements in my, so let's do this. Remember NE, so let's first define what NE is, like literally. So N of E That's literally the number of elements or members in the event, and ns is going to be ns. It's going to be number of elements in the sample space. All right. All right. So that's the formula for a probability. Right there. That's given. Okay. So what is this saying? This is saying that if I want to figure out the probability of an event happening, the first thing I need to do is to figure out what is the number of elements that is inside my event. That's the first thing. And then the second thing I need to do is to figure out what is the number of elements that is inside my sample space, and then divide the two, and that's going to give me my probability. But usually we typically find the number of elements in the sample space first, then find the number of elements in the event, then we divide them. Very simple. The letters stuff may look weird, but it's a very simple idea. So it's the probability model for equally likely outcomes in an experiment in which all the outcomes are equally likely. So that must be the case. All of the outcomes must have the same likelihood or same chance of happening. So you can't have no unfair game or unfair experiment where, with the dice, you have, constructed the dice such that the dice always lands on 4 or the dice always lands on 2. That's not going to be where the outcomes are equally likely. Number 4 have a better chance than the rest of them, so it's not equally likely. All right. Or it can be where, you feeling in if you looking in a bag and you could feel the fruits, right? Then you know what fruit you're picking up. So you know whether you're picking up a pear versus whether you're picking up, say, a grape. So that's not equally likely. For equally likely, you want whereby it's no unfair advantage. Okay? It's random. Each um each outcome has an equal chance than the other one. There's no reason to think why head has a better advantage than tail. And there's no reason to think why tail has a better advantage than head. All right, it's equally likely. If that's the case, then you can apply this formula, which says that the number of elements in your event divided by the number of elements in your sample space is going to give you the probability. Now, it might sound confusing, but it's actually a very simple idea. And with a few examples, we could be able to understand exactly what's happening. Okay, so let's begin with the examples. So you can start with the characteristic or the frequently used examples, and it brings everything together. So experimental examples, and good. No, okay, so let's keep that down. All right, so let's say, for example, number 1. So the experiment is that you roll a fair dice. Okay, Now, if we roll a fair dice like we learned yesterday, not yes, yeah, we learned in previous classes. If we roll a fair dice, yeah, if we roll a fair dice, Jasmine, what's gonna be my sample space? If I roll a fair dice. Jasmine, what's gonna be my sample space if I roll a fair dice? Jasmine, go ahead. Okay, so I guess I'll ask Deshaun, what's gonna be the elements in my sample space if I roll a fair dice?
1 to 6.
1 to 6. Very good. So it's gonna be 1, comma 2, comma 3, comma 4. We could do this in our sleep now, comma 6. Good. Now what I want is I want the number of elements that is in my sample space. So let me ask Rashad, what's going to be the number of elements that is in my sample space? Go ahead, Rashad.
6.
6. Very good. So the number of elements that is in my sample space is going to be 6. And the reason why is because I literally have 6 numbers inside my sample space, like literally 1, 2, 3, 4, 5, and 6. All right, so that's that. Now, what if
Sir,
go ahead.
number of elements.
Yeah, the number of elements in S is 6. Okay. I think what I should have done, and please forgive me for this. Number 1 should read find the probability or determine the probability of rolling a fair dice and getting an even number. That should be the question. So please forgive me. So what we're doing now is basically how to answer the question. So the question is, we want a probability of rolling a fair dice. What's the probability of rolling a fair dice and getting an even number? So the experiment is rolling a fair dice. The sample space is 1, 2, 3, 4, 5, all the way up to 6. The number of elements in our sample space is going to be 6. Now, remember my event. My event is E, which is I want to get an even number. And so that means that my event is going to include which numbers, Miss Neely. My event E is going to conclude with numbers.
You mean me?
No, I mean F Neely.
Yeah, even 0 to 2, 4, and 6.
Very good. 2, 4, and 6. Right? We cannot include 0 in this because 0 is not a part of the sample space. So
Yeah.
only the ones that are 2, 4, and 6. Very good. Now, Caitlin, what's going to be the number of elements in my event?
Three.
3. Very good. 3. The number of elements in my event is 3. Good. Now, Deja, this one is for you. But let's put it all together. What's going to be the probability of my event?
3.
Okay, how did I get 3? Very good question. I got 3 because there are 3 numbers in E. 1, 2, and 3. All right. There are 3 numbers in L. Okay, 1, 2, 3. Okay, so let's put it together. Deja, what's going to be my probability of getting an even number?
Okay, so our numerator would be
Uh-huh.
12.
Our numerator is going to be what?
12?
12? How? How 12?
I don't know. You said, okay, it says number of favorable outcomes.
Yes.
So not even?
Yeah, what's the number of elements in in E?
Oh, sorry, I didn't even see that. Okay, yeah, 3.
Oh,
So
gee.
that'll be 3. The numerator will be 3.
Oh
Sorry.
my goodness, you have me have me freaking out. Alright, the number of elements in my event is 3.
3.
Right? Because there are 3 even numbers. And how much numbers I have in total?
6.
6. Very good. Okay. And so that means that the probability of getting an even number is what?
3 out of 6.
3 out of 6. Alright. Now we could simplify it. You always want to simplify it. If we simplify this fraction, Deshaun, what number could we use to simplify it? Deshaun, Adderley, what number could be used to simplify this fraction 3 over 6?
1/3.
It wouldn't be 1 over 3.
2.
You can't use 2. What number could we use? I heard someone said it. We could use 3 to simplify it.
3.
Excellent. 3. Now we can't forget how to simplify fractions. That's something you learn in grade 6. And the reason why I know that is because my GLAD crew, we just finished doing simplifying reducing fractions. So that's grade 6. So don't forget those skills. So we have, so we're going to divide the top number by 3 and we're going to divide the bottom number by 3. Alright, so we need a symbol division. So divide by 3. Alright, so we divide the top by 3 and then we divide the bottom by 3. Good. Once we divide the top by 3 and the bottom by 3, what do we get? What is 3 divided by 3? Cyan. I think Cyana is her name. Cyana. What is 3 divided by 3?
Me?
Yes. What is 3 divided by 3?
1.
1. And what is 6 divided by 3?
2.
2. Very good. So that means that the probability of getting an even number when we roll a dice, a fair dice, is what? Is what? Is 1 over 2.
50%.
It's a half. I
Mhm.
can barely hear you. Oh, 50%, you said. 50%, yeah. 50%. Okay. Any questions?
No, sir.
No, okay. So what do we do? In order to find the probability of this event, which is getting an even number, the first thing we do is we determine our sample space, right? And then we look at the number of elements that is inside our sample space, which is 6. Okay. And then we look at our event, the event that we need. They told us in the question, the event is getting an even number. And it's 3 even numbers that are part of our sample space. So it's going to be the number of elements in the event is going to be 3. So the probability of an event, the event that I get an even number, is going to be the number of elements in my sample space, the number of elements in my event divided by the number of elements in my sample space, which is 3 over 6, because the number of elements in the event is 3 and the number of elements in the sample space is 6. So 3 divided by 3 is 1 and 6 divided by 3 is 2. And so that means that the probability of an event, the event that I get an even number, is a half. All right. Okay, so that's the first example. So you see, that is why we had to know what an experiment is. We had to know what is the sample space. We had to know what an event is, and we had to know what the number of elements in the sample space and event are, because all of them come together to finally give us the definition of probability, right? That's cool. So all of the things we've been learning thus far, sample space, events, outcomes, elements, experiment, all of them come together and culminate at this definition that helps us to determine the probability, the theoretical probability of an event happening, provided that what? All of the outcomes are equally likely to happen. All right. Okay, so let's do number 2. All right. Okay, so we want this to go well. All right, so what if I say determine the probability? Oh my goodness. Deja, where's Sierra?
I'm not sure.
I know you don't know. I don't know either. That's really bothering me. She should have been out. Determine the probability of choosing. Okay, no. So sorry. A letter is chosen at random from the word Jasmine. All right. Determine the probability of choosing or of selecting a letter that is a vowel. All right. Okay, good. So, Deja, what's my experiment?
Randomly choosing a letter from the word Jasmine.
Randomly choosing a letter from the word Jasmine. Rashan, what's my sample space?
J A S M I-N-E.
I-N-E. Very good. Now, Jasmine, this is your name. I hope you don't mind us using your name.
Pardon?
I say this is your name we're using. I hope you don't mind us using your name.
Oh.
What's the number of elements in the sample space, Jasmine? The number of elements in the sample space, Jasmine. Go ahead, Jasmine. We just heard you.
Oh, I thought you were saying
Yeah, what is the number of elements in the what's the number of elements in the sample space?
6.
6, you sure?
Hold on. Wait, that's 1.
1? The number of elements inside this sample space.
7.
Exactly, 7. So 1,
Oh,
2, 3, 4, 5, 6, 7. We basically asking you how much letters in your first name. Good. So now we want the event. Now this one is interesting. The event E. What is the event E, Caitlin? What do you think the event is?
All vowels.
Okay, selecting a vowel. Very good. So selecting a letter that is a vowel. And what goes inside this event, Caitlin?
The vowel is the name.
I could barely hear you. Say it again. What goes in it?
A, I, E.
A, I, and E. Very good. A, I, and E. Now, Sayana. I hope I'm saying your name right. If I'm not, please correct me. What are the number of elements in the event?
3. And it's
3.
Sienna.
Siana. Okay, thank you. 3. All right, now for the grand finale. Who wants to do the grand finale? The probability of the event.
Can I do it?
Go ahead.
Okay, so the probability of that
Uh-huh.
is 3
Uh-huh.
over 7.
Excellent. 3 over 7. Excellent. Very good. It's going to be the number of elements that is in your event divided by the number of elements that is in your sample space, which is going to be equal to 3 over 7. Experiment, event. Good. All right. 3 over 7. Okay, good. How do we get 3 over 7? Well, there are 3 vowels in this word. Okay, that'll be a top number. And then there are 7 letters in total. That's in your sample space. And so it's 3 over 7. Very good. I like these examples that we're doing. We're getting there. I feel like we're getting to these probability questions. So I like it. Any questions? So I like that everything is coming together with us learning the concepts and actually seeing how they work together in unison and combination. So this question can easily come on your exam. Like, okay, we give you the letter the word jasmine. We want you to select only the vowels. What's the probability of selecting or choosing the letter as a vowel? Well, it's going to be 3/7. Now, we don't need to simplify this fraction because it's already in simplest form. Go ahead, Altonique. Go ahead, Altonique. Just gonna say something?
It has to be never mind.
Okay, okay. All right. Okay, so what if we say, there's another example, we can say, a number is chosen at random from 1 to 10. Determine the probability that the number chosen is a multiple of, multiple of 5. Good. Deja, what's the experiment?
Okay, randomly choosing a number from 1 to 10.
Randomly choosing. All right. Oh, before I forget, since most of us are here, please send the class notes after class, please. I notice that some of you have not been sending your notes. A lot of you have, and I thank you for those who have been sending your notes. That's good. But some of you have not been sending in your notes. I can call some names, but I won't do that. I won't put you on the spot today. But please send in your notes. All right. Some of you participate in class, and that's good. But I need to see your notes. That means that you're writing something down. You should not be idly doing nothing. You should be with your pen and your paper at hand, and you're writing down the notes. All right. So the only way you can know is if you have submitted the notes. That's the only way I know that you're paying attention, because I need you to be paying attention. All right. And so please send in the class notes. If you don't send in the class notes, then we don't want to have to go through that method. All right. So please send your class notes so that all will be well with you and with me in this class. All right. Okay. So randomly choosing a number from 1 to 10. What's going to be our sample space, Miss Neely? F. Neely.
1 to 10.
1 to 10. Very good. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Now let me space this on. Let me put some commas there. So let's see if he did it right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Very good. Now Miss Neely, F. Neely again. What's going to be the number of elements in my sample space?
4, 6, 8, and 10.
No, the number of elements in my sample space. In my sample space.
Is it 10?
10. Very good. The sample space is what the numbers that are in here. All right. So the number of elements in my sample space is X is definitely 10. Good. Now, Miss Neely, what is my event?
Would that be the sorry about that 4, 6, 8, and 10?
Why you say 4, 6, 8, and 10? What event we're trying to determine the probability of? If you look at the question, what event we're trying to find the probability of?
Can I try?
Sorry, 5 and 10.
5 and 10, very good.
Yes,
So
sorry.
the event that we're trying to find, we're trying to choose, randomly choose, or we're trying to choose a multiple of 5. And what's going to be in that event? She said at 5 and 10. Okay, good. Now, Miss F. Neely, what's the number of elements in my event? Miss F. Neely, what's the number of elements in my event? Okay, I guess she's not here. You could go ahead, F. Neely. F. Neely.
Would it be 1, 2? It would be 1, 2, 3, 4, 6, 7.
The number of elements in my event. So,
10.
no, the number of elements in the event. How much elements are inside the event?
Oh, 2. Sorry about that.
2. Very good. All right. So remember, when we ask for the number of elements in the sample space, we're talking about how much numbers are inside S, inside this set. Okay. When we talk about the number of elements that are in our event, we're talking about how much elements are inside this set. Okay. Okay, good. So now, Miss F. Neely, bring it all together. What's going to be the probability of the event?
Can I say answer again?
No. Right after. Once I give you opportunity, Albanique.
It's 1. No, 2 over 2.
You say 2 over 2?
Yes.
Why you say 2 over 2? So
Yeah.
remember that the top number is the number of elements in the event. So that's going to be what you said, 2. That's correct. But the bottom number is what?
3. Oh, 3.
The number of elements I have in my sample space. So how much elements I have in my sample space?
Oh, 10.
10, yeah. Very good. So it's 2 over 10. So essentially what we're doing is, for this experiment, we randomly choose a number from 1 to 10. And we're trying to figure out what's the probability of me getting a multiple of 5. there are only 2 multiples of 5 in this entire set, and the set contains 10 numbers. So the probability of me choosing a multiple of 5 from this set is 2 over 10. Okay, so that's better than mine. So we could still simplify this. What number we could use, Albany, to simplify 2 over 10?
2.
2, very good. So if we use 2 divided by 2, Albany, is what?
81.
Very good. And what is 2 divided by 10?
5.
5, very good. It's going to be 1 over 5. So what did we do? The first thing we did, we found out how much numbers that are in my sample space, my entire sample space, and that's 10. And then I determined, well, how much numbers that are in my event. That's 2. And so that means that the number of elements in my event is 2, and that's going to be divided by the number of elements that are in my sample space, which is 10. Simplifying them, I get 1 over 5. So the probability of me choosing a number that is a multiple of 5 at random is going to be 1 over 5. Okay, so let's actually do some examples or some exercises, that's the word. The first one is determine probability of getting an odd number. This is number 1. Number 2. no, I don't want to use that. I can't use that word. It's has a double A. Gives Albernic. No double Q. Oh, it's confusing. Yeah, we could use that, Taisha. Let me change the name. I don't want to use this one because it could get confusion. Let's say, yeah, Rashan is good. Rashan is pretty good. Yeah. Yeah, that's good. And then okay, so those are your 3 examples or practice problems. So determine probability of rolling a fair dice. Well, let me start the timer. We have 2 minutes on the clock for you. And the timer has begun. So for this one, you want to determine the probability of rolling a fair dice and getting an odd number. The next one is we want to determine the probability of selecting a letter, of choosing at random a letter from the word Srashan and getting a consonant. For the third one, we want to determine the probability that the number chosen is a multiple of 4 once we choose at random numbers from 1 to 10. So those are our questions. We have a few moments to answer them. All right. Can begin with the first one because that's time. Okay, so all right, let's begin with number 1. So Sienna, I want you to help me with number 1. What is the experiment? Go ahead, Sienna. Help me with number 1. Oh, I don't know if y'all can hear me. All right. All right, can y'all hear me? Hello? Can y'all hear me? I don't know if they can hear me. I don't believe they can.
Can't tell. Okay.
Roll of a dice. One, two, three, 4, 5, and 6. Six. Getting an odd number. One, 3, and 5.
I could do the next one. Jasmine.
3. 3/6. 1/2.
Choose a random letter from Kishan. R I S H A N. That's it. Select a letter that is consonant. RSHN. And that's 4. Over 6. Oh, over 6. No, I don't think so.
Yes, sir.
Two. Two.
Two.
3.
Caitlin had to go somewhere.
I can do it.
Yes, sir.
Um, choose a number at random. A number from 1 to 10. One, two, three, four, five, six, seven, eight, nine, 10. Ten. Choosing a number from the numbers. Choosing a number from no, the numbers chosen is multiple of 4. Four and 8.
Two. 2 out of 10. Yes, so. 2. 1/5.
I got a 3 out of 3.
3 out of 3.
I got better too.
You said counter? Counter? I think it was a counter, like a counter, a little counter. Yeah, or in the kitchen. Oh, okay.
Oh, it looked like the things what they use for bingo.
Like just circle A or B. Right?
You have to rate all of this. Oh, my bad.
So we just like doing the events and all that stuff. If you just answering the question with the event, the number of events, and the current event. The fraction.
I have a question. This is you're saying it's number 1, 3, 4, 5, 8, 9, right? But that's not the order. But will that still be a sample space, or it's not in order for number one? You said it was numbered 1, 2, da da da. But I asked it if that would be a sample space or one. Okay.
So that's maybe just doing the number of elements and the number of sample spaces. So just the fraction.
Uh, 6. Um, I have this thing. Oh, 2. You said even numbers. 4. A 9. 2, 3.
Okay, so I go 1/6. Because 8 is so. I mean 2/6. 4 and 8. When you simplify it, it'll be 1/3.
Me.
Yes, sir.
So the sample space would be 1 to 6, and the prime numbers would be um the prime numbers would be 1, 3, and 5. So that'd be 3/6, and it could be simplified into. Yeah, so no,
What if
my God. Okay, so it'll be 3 and 5. So 3 and 5 over, that'd be 2/6. I said that at first. 2, 3, and 5. So that's 3. So it'll be 3/6, and it could be simplified. And it's simplified. It's it's 1/2 because we divided into 3.
um I have 1/6. Yeah, because that's the only square number in the sample space. Oh, uh, yes, sir. Or unless one is one, because none of the other ones are. I don't know. I just was like, you sometimes you say don't put one, so I didn't put one, but I guess so. So I guess it would be 2/6. 2/6. 1/3.
6/6. Because all of them are whole numbers. One whole.
Pardon me? Oh, I didn't answer that yet. I think it's 4, I think.
2.
No.
1.
Why
Yeah.
and 8?
Because there's only one cube number? I mean, wait, no. Yeah, hon. 1.
Hold on, I got a question.
1
For the
second.
cube number, for the cube number, I think it says it could be multiplied by 3, right? Might? I would think it's 6 because 2 times 3 is 6.
4.
But it could be 1. Probably goes 1 times 1 times 1.
One. One. Oh, so it's or six. I ain't too sure about that one. Two over six. One over three.
Excuse me. I thought 8 was a cube number.
18 on the 1 in 1, 2, 3, 4, 5.
Okay.
All of them are integers. 6 out of 6. Uh-huh. It's negative and positive whole numbers.
Oh, it's 2
6. 2, 4, 6. 3, 4. 2. Just 4.
Sorry, I couldn't hear you. I think you were calling me. I have 5 or 6. One, 2, 3, 4, and 6. That'll be your whole 0 and up. No, 1 and up. 0 and up. Oh, I don't want and up. I mix it up with counting numbers. Okay, so natural numbers like a counting number, 1 and up.
Me.
I am getting too long.
Excuse me. So the numbers like going up to 6. So like if we have a number like 8 and it's supposed to be now, we don't put the number, we just put 6. So we just writing a consonant and a vowel letter.
I finish. Nine over 12, and it could be simplified into because I count the consonant. So you gotta divide it by three, so it'll be 3/4, because 3 times 9 is 3. Over 4.
I get 3 out of 12. One over 4. Yes, sir.
For and nor, but, or, yet, so. Yet. Yeah, we could say the ride lasted just a few minutes, yet my stomach continued to rumble for hours. Does that sound weird? I mean, okay. Pardon? You call me? I don't know. Would you put and also? Okay, so you could use a semicolon.